Thanks for the introduction. Hello, everyone. Good afternoon. And today, I'm very excited to share our work on unlocking the efficiency in real-world collaborative studies through a multi-site international study with COLA-GLMM. First, I would like to thank the efforts made by the OHDSI community with over 3,000 collaborators across the whole world, and the number now increased to 4,000, as George introduced this morning. And a significant amount of real-world data have been leveraged to use to generate a robust and real-world evidence. And more importantly, these efforts facilitate open science by promoting more and more international studies. However, one of the primary challenges in international study is the inability to share individual patient-level data across different sites. And the time-consuming regulatory approvals process and the diverse laws across different countries make the international study really complicated. And under such context, the privacy-preserving federated learning algorithms become very important. And these algorithms enable fitting the statistical model in a distributed manner and only require the sharing of summary-level statistics instead of the patient-level data. And such feature can ensure the data privacy and security. A remarkable thing is that within the OHDSI research network, a large number of federated learning algorithms have been successfully implemented. For example, distributed linear mixed model, also termed as DLMM, has been applied to analyze the data from 11 databases from 3 different countries. And the objective of this study was to investigate the association between the demographic and clinical characteristic with the continuous outcome, which is the length of hospital stay for COVID-19 patients. And for this DLMM algorithm, it has 2 ideal properties for federated learning algorithms. The first property is called lossless, which means that the results by using federated learning algorithms would be identical to those by using the pooled analysis. It means that there is no accuracy loss due to the data sharing constraints. And the second property is called one-shot, which means that when we implement the federated learning algorithms in a practical setting, only a single round of communication is needed. And to date, only a few algorithms have successfully achieved both lossless and one-shot properties. One is linear regression model, and the other is the linear mixed model that I just introduced. However, given the diverse nature of real-world data, there are other types of outcomes available beyond continuous outcome. And also, when we do multi-site analysis, the between-site heterogeneity problem is the key consideration. So it is very important for us to develop the federated learning algorithm for generalized linear mixed model. And efforts have been made along this line of research, but given the complexity of the real-world data and also the nonlinearity of the estimating functions, the existing methods are not able to achieve both lossless and one-shot features. And here today, I would like to introduce our new method, COLA-GLMM. And COLA-GLMM stands for Collaborative One-Shot Lossless Algorithm for Generalized Linear Mixed Model. And this COLA-GLMM algorithm operates under the assumption that a common set of covariates should be available at all collaborating sites, and these variables should be standardized into categorical variables. And the pipeline of COLA-GLMM is that for each collaborating site, they will use their own patient-level data to generate some summary-level statistics. For example, we have the patient-level data have 2 covariates, one indicator for female and one indicator for age larger than 65. And we're interested in a binary outcome. And here, the generated summary-level statistics include, first, all possible combinations for the 2 covariates. And then we're going to count the number of patients matching the unique combination. And also, we're going to calculate the sum of outcome values and the sum of outcomes times the covariates for each unique combinations. And this procedure will be done independently and in parallel within each collaborating site, and the summary-level statistics will be transferred to the coordinating center for feeding GLMM model so that we can estimate the parameter of interest, for example, the fixed effect and the random effect. To demonstrate the performance of our COLA-GLMM, we have run some simulation studies. And we first compared the pooled analysis with the most commonly used method for evidence synthesis, which is the meta-analysis method. And when we try to simulate the setting, there exists some level of heterogeneous set level of random effects. From this figure, you can see the meta-analysis method cannot have very accurate results compared with the pooled analysis. And then we compare our method, COLA-GLMM, with the pooled analysis. And then from this figure, you can see the results show the lossless property of COLA-GLMM, which means our method can produce exactly the same as the pooled analysis in estimating the fixed effect. We also consider a practical concern related to the risk of re-identification problem when there is a small cells issue. And here we follow the CMS cell suppression policy, and you can see our method is robust enough to provide similar results as the pooled analysis. And we apply our method to the real-world setting, and we aim to identify the COVID-19 mortality risk factors. And we also want to check the consistency of these significant risk factors. And we collaborated with 8 different data partners across 3 different countries within the OHDSI research network. And finally, we found sex, the Charlson Comorbidity Index, and age consistently emerge as the significant risk factors for COVID-19 mortality. To summarize, here we propose COLA-GLMM, which is a lossless, one-shot, and privacy-preserving algorithm, and it is able to handle the between-set heterogeneity. And more importantly, our COLA-GLMM is applicable and ready for implementation within the OHDSI research network. And finally, I want to thank all of the data partners and our collaborators. If you have any questions, please feel free to stop by poster 117. Thank you very much.